Hello everyone, this is Mainak and you are watching Civil Bro channel, and today we are going to discuss about the lapping zones which are provided in beams at site. Also we are going to discuss about the beam drawings in the next segment of the video. So let's get started. So as you can see, this is a span of a beam. We start from here and then it goes up to this much. So if you consider this the span of the beam or the L, and you can also take the L from the center to center distance, or from the outer also you can take. So now in the drawings it is given that for the bottom portion, the lapping which is provided, as you can see, lapping is to be given at a distance of L by 4 from the supports. So if we take this end, leaving a distance of L by 4, we have to provide the lapping of the bottom reinforcement. But you will see in many videos that they advise to give the lapping in the bottom, in the junction or in the starting. They do because if you see the structural analysis, this portion has the minimum moment in the bottom fiber, so that's why they do. But in one IS code, I'll mention that IS code in the as you can see in the description, I'll mention that IS code. So in that IS code, that in the junction it is prohibited, but sometimes we have to give at the junction as well. Suppose you can see here we have 3 bars. Now 3 bars, 2 bars lapping is provided there at a distance of L by 4, and this bar in the third bar is provided at the center. So and another again you can see here at a distance from L by 4 from that span, another lapping is given. So when we calculate the rods, we have to do accordingly so that the cut pieces align accordingly. And as you know, if you see the structural analysis diagram, then you will know that the moment is minimum at the center for the top fiber. So the lapping is provided at the center, and you can see this top reinforcement. And if there are more than 2 rebars, as you can see here, so it can be given in a staggered way as well. So one is like this and one starts from here. So staggered arrangement can also be done for if you have more than 2 rebars in the case of top reinforcement. So here, as you can see, if you see this rebars, you can see here, this is 25 rebars have been used of Fe 500 steel. So 500 Newton per mm square is the steel strength, and as you can see, the lapping is provided like this. A bit of joggle is given here, and 50D lapping is given. So if it is 20 bar, it is 1 meter, and it is if it's 25 bar, it is 1250. So like this you calculate the lapping length, and you can also see the development length which is provided here for the bottom rebars. Development length, it starts from here and it goes up to here. So this is the development length, and similarly for the bottom this beam also. So the top rebars are, or you can see the top rebars here and the bottom rebars as well. So now you can observe here the lapping which is given in the top fiber as well. It starts from here. So it starts from here and it ends here. So like this lapping is provided, and these are the stirrups which are provided in the beam. And as you can see, the hooks are bent at a distance at a 135-degree angle. So it shouldn't be like this, it should be like this, 135-degree angle. So these are the things, some things which you can observe at the site: the diameter of these particular bars, and then the diameter of the stirrups, and the spacing between the 2 stirrups, center to center spacing between 2 stirrups. Here it is 100, 125, whatever you can check the spacings. And then if there are extra bars here, now the extra bars they have not fitted, they will provide it shortly. So the extra bars also you can check. So now we'll move on to the drawing and see some of the aspects of the drawing part as well. The framing diagram of the particular building. As you can see, there are various beams which are marked as TB1, TB2, TB3, TB4, TB5, TB6. So this is the layout. So if you want to see the details, let's see the details of a particular beam. Let's see the details of TB6. So TB6 has a size of 450 into 750, and the section along which it is cut in this particular diagram is also given. You have to refer to both this particular diagram, that is this one, that is B grade and which is cut from here, as you can see here. So this is the cutout, and here you can see. Let us see the main reinforcement first. So the main reinforcement which has been used here as marked by ALTH, which means all through. So at the top we have 22 bars of 20 mm dia, which is all through in this particular TV7. So if you go to TV6, similarly you can see here in this TV6 4 bars of 25 mm bars is all through ALTH in this span, and in the second span, as you can see here, in the second span also we have the same all through bars. And if you talk about the extra bars, as we know, in the top the extra bars is provided at the at the ends, and this is the discontinuous end. It is provided up to 2400 from the column outside face or the inside face of the column, and in this continuous span it is provided 2400 on this side and 2200 on this side, and it is provided like this in the discontinuous end again. So generally there is a calculation involved here. We'll talk about that, and what is the codal specifications and standards for this. So generally this 0.3L in the discontinuous and 0.1L in the 0.1L in the discontinuous end and 0.3L in the continuous end. So like this it is there, and in the bottom also the total length of this is 0.6L of extra. We'll discuss about that, but first let us understand this diagram and let's see what is the reinforcement provided in the bottom. So bottom we have two spans of this TV6, and in the two spans we'll have the all through bars of 4 bars of 25 mm. So 4 bars of 25 mm is all through, and for the bottom, as we know, the extra bar is provided at the center. So at the center we have extra bar of 4 bars of 25 mm. So we have total 8 bars here. 4 bars is all through and 4 bars is extra. Similarly here also we'll have 4 bars of 25 mm as your extra. So in the bottom we have 4 bars as all through and 4 bars as extra, all of 25 mm. In the top we'll have 4 bars of 25 mm as all through and 4 bars of 20 mm as extra. So total 8 bars in both in top and the bottom we are having in this TV6. So now we'll have a look at how the extra bars are provided at our site. So as you can see now, currently all the lapping have been provided. You can see this is the top reinforcement, extra top. On the end, right end, you can see here this is the continuous end, and this is the extra bottom which is provided. We'll show it later. This is the extra top. As you can see here, we have 4 bars here of 20 mm at the top, and in the bottom also you can see the extra bars. So you can see these bars, how the spacer bar is also given. You can see spacer bar of 25 mm is also given to separate between the two. You can also see that, and the bottom reinforcement, extra bottom, you can see the extra bottom will start from here, that is at the center. You can see the extra bottom reinforcement, and if you go further, and we'll show you this is the lapping of the bottom reinforcement at a distance of L/4 from the end, the lapping zone as per our drawing. So that's all for today. For more updates and videos on related to site and software of civil engineering, subscribe to our channel and also like this video. It really helps us to grow and reach more like-minded people like you. So thanks to all civil engineers. Keep growing, keep learning. Mainak signing out. Bye.